Right now, 700 miles from any coastline, a nuclear-powered floating city with 6,000 people on board pushes through hostile waters. Two massive ships race side by side at 30 miles per hour, linked by fuel hoses pumping thousands of gallons every minute. One wrong move, just a 1-degree steering mistake, and both vessels could ignite in a fireball visible from space. This isn't Hollywood. This is how America's aircraft carriers stay alive at sea. And the danger is far greater than most people imagine. The USS Gerald R. Ford, the most advanced carrier ever built, weighs 100,000 tons and costs $13 billion. But none of that matters if it can't refuel, restock, and reload while thousands of miles from home. What almost no one knows is that keeping these giants operational requires some of the most dangerous maneuvers ever attempted on open water. Every day, American sailors risk their lives in operations. So risky, even veteran captains break into a cold sweat. These billion-dollar ships move within 30 yards of each other, racing across rough seas, tied together by cables that could snap without warning. The stories you're about to hear have rarely been told. From Red Sea combat missions where enemy missiles target supply ships, to Arctic operations where one mistake equals death in freezing water. If you support our Navy and want the truth about these death-defying missions, let us know in the comments. Let's start with something shocking. When the USS Harry Truman deployed to the Red Sea in 2025, it faced the most intense combat a carrier group had seen since World War II. Houthi missiles and drones targeted the ship non-stop. But here's what most people never hear. Right beside Truman, under the same enemy fire, was a supply ship, USNS Arctic, with 140 civilian crew members. Think about that. While fighter jets launched strikes and defensive systems shot down missiles, Arctic was pumping jet fuel and loading weapons onto Truman. The Rear Admiral said something chilling. Since World War II, we haven't seen battles like this. And the only reason we survived was because Arctic stayed beside us. During that deployment, Arctic sailed 244,000 nautical miles, 10 times around the Earth, delivered 124,000 pounds of ordnance, and completed 135-plus replenishments while enemy forces actively tried to sink them. But you don't need to be in a war zone for these missions to turn deadly. Even in peacetime, the physics alone are terrifying. Imagine two of the biggest moving machines humans have ever built, each longer than 3 football fields, racing across the ocean. The carrier weighs 100,000 tons. The supply ship, 50,000. They move at 12 to 16 knots. Nearly 20 miles per hour for vessels is huge. Here's the horrifying part. When two massive ships run side by side, the water between them creates suction, an invisible force pulling them together. Engineers call it hydrodynamic interaction. Sailors call it the kiss of death. At precisely 12 knots, a 1-degree steering error, about the width of your thumb at arm's length, creates a sideways drift of 20 feet per minute. In just 3 minutes, that tiny mistake can push these floating cities close enough to touch. And when 150,000 tons of steel hits another 150,000 tons of steel at sea, it's not a bump. It's an explosion heard for miles. This actually happened in 2004 to the USS Lake Champlain. During a routine refueling, something went horribly wrong. The crew had to execute an emergency breakaway, basically ripping apart every fuel line and cable between the two ships while both were still moving. Fuel sprayed everywhere. One spark could have turned both vessels into a fireball and wiped out every sailor on board. But here's what makes our Navy incredible. They've mastered these operations so well that accidents like this are extremely rare. The level of skill, training, and raw courage required is beyond what most people can imagine. So how do they even pull off these death-defying missions? It starts with a procedure called the Standard Tension Replenishment Alongside Method, or STREAM. Ignore the technical name. This is pure high-speed precision. A supply ship, usually a Henry J. Kaiser class or the newer John Lewis class oiler, sets a steady course and speed. These aren't normal cargo ships. The John Lewis class is 745 feet long, carries 156,000 barrels of fuel, and uses 4 huge gas turbines that let it keep pace with carriers moving over 30 knots. The carrier then approaches from behind and slightly to the side, closing to within just 30 yards of the oiler. To picture that, You could stand on one deck and toss a baseball to someone on the other. Except here, both ships, massive steel giants weighing tens of thousands of tons, are moving at highway speeds through 20-foot ocean swells, pitching, rolling, and fighting the sea. Once in position, the supply ship fires a thin shot line using a pneumatic launcher. This lightweight line snakes through the air and pulls heavier messenger cables across the gap. Those cables then haul over the real heavyweights, the high-tension lines that connect to a sophisticated system of ram tensioners, machines that constantly adjust for the unpredictable motion of both vessels. These tensioners prevent the lines from going slack or snapping as the ocean heaves beneath them. Now comes the part that even seasoned sailors dread. Fuel hoses, some nearly 7 inches wide, are locked between the ships, and within seconds, thousands of gallons per minute of highly explosive jet fuel and diesel start surging through them. It's enough raw energy to power a small city, all traveling across a moving bridge of steel and cable. And it's not just fuel. Ammunition, including multi-million-dollar guided missiles, food pallets, fresh water, spare parts, medical supplies, mail, even tubs of ice cream, travel the same narrow gap. Weather turns this already dangerous mission into a nightmare. High winds can snap steel cables like thread. Heavy rain kills visibility. Fog blinds even most experienced crews. And big waves can slam 2 warships together with catastrophic force. During hurricanes, carriers flee to safer waters. But in combat, there's no retreat. They must take supplies, no matter the risk, because the fleet's survival depends on it. The sailors running these operations need nerves of steel. On the carrier's deck, crews handle high-tension lines under extreme pressure, while fighter jets are launching and landing just feet away. One wrong step, one jam winch, one snap line can kill instantly or destroy aircraft worth hundreds of millions of dollars. Everyone on deck knows the stakes. Consider the crew of the USNS Arctic during their Red Sea deployment. These weren't active-duty sailors. They were civilian mariners with military sea lift command. For 9 straight months, they kept critical supplies flowing while operating under routine missile and drone threats. They delivered fuel, ammunition, mail, and yes, even ice cream to ships in combat conditions. Their courage earned 9 of them the Navy Civilian Service Achievement Medal. Precision is everything. Helmsmen steer with the focus of Formula One drivers, making micro-adjustments every second. The bridge teams stay locked in for hours, monitoring every inch of distance and every shift in current. Supply ships must approach carriers on the exact same starboard side, every single time, following procedure perfected over decades. Technology helps. Automation, advanced navigation software, stabilized cranes, and helicopters capable of lifting 4,000-pound loads all reduce risk. Now, drones and unmanned systems are being tested to handle even more of the load, potentially taking humans out of the riskiest steps. These missions are more than logistics. They're strategic lifelines. Without underway replenishment, U.S. carriers will be chained to ports, unable to project power worldwide. America's rivals understand this. Nations like China are developing weapons and strategies designed specifically to target resupply ships because cutting off fuel is far easier than sinking a carrier. And the challenges keep growing. The Navy is bringing new light replenishment oilers, TAS, online, designed for distributed operations. Climate change is producing harsher, less predictable storms. Arctic missions are increasing. Cyber attacks, submarines, and long-range missiles make the logistics chain more vulnerable than ever. So next time you see a U.S. aircraft carrier powering across the ocean, remember the hidden danger behind its strength. Every mission, every deployment, every show of force depends on quiet, relentless work of military and civilian personnel who risk their lives to keep the Navy supplied. They are the backbone of American sea power, and they deserve our respect, our support, and our recognition.